Imagine building like 100 beautiful, structurally perfect bridges.
Okay, I'm picturing it.
Right. So they look completely flawless on the blueprints. The engineering math checks out perfectly.
Yeah.
But imagine that the moment a single car drives onto them, 60 of those bridges just instantly collapse.
That is terrifying.
It really is. And in the tech industry right now, that exact scenario is happening literally every single day with artificial intelligence.
Oh, absolutely.
Like over 60% of AI projects never even leave the prototype phase. They just, shatter the moment they touch the real world.
It is honestly the ultimate engineering heartbreak.
Yeah.
And the crazy thing is, the reason for this massive failure rate, well, it isn't bad math.
Right.
It isn't a lack of brilliant algorithms or missing data or anything like that. It is a complete lack of systemic architecture.
Wow.
Yeah, we spent the last decade obsessing over how to train models, but we completely forgot to build the ecosystems that those models actually need to survive.
Okay, let's unpack this. Because today's deep dive is all about one of the most lucrative and honestly most fascinating transitions happening in tech right now.
It's a huge shift.
Massive. We are looking at this evolution from the traditional data scientist to what's now called the AI architect.
Right.
We're moving away from this purely model-centric focus toward a system-centric focus. But, to understand why companies are suddenly desperate for architects, we first need to understand the problem.
Exactly.
So what is that fundamental wall that traditional data science keeps hitting?
Well, to understand the wall, you really have to look at what data scientists actually do all day. Fundamentally, they are translators of uncertainty.
Translators of uncertainty. I like that.
Right. They take statistics, machine learning, business domain knowledge, and they use all of that to extract patterns from chaos.
Which is hard work.
Very hard. Their day-to-day is pure exploration. They clean data, they engineer features, they run cross-validations to build these predictive models.
Which sounds exactly like what you want them to be doing, right? Like if a company wants to predict customer churn, they hire a data scientist to find the pattern.
Yes, exactly. But here is the problem. It's the environment they work in.
Sure.
Data scientists traditionally work in what we call a sandbox.
Sandbox.
Right. It's this local, isolated environment, usually just a notebook running on their specific laptop or maybe a single dedicated server.
So it's safe.
Too safe. In that sandbox, the data is static. It's basically a frozen snapshot of the past, so the model learns perfectly.
Yeah.
But production, the real world, is not a sandbox. Production is a hurricane.
And that brings us back to the data I mentioned earlier, the 60% failure rate. But why? If the algorithm is mathematically sound in the sandbox, why does the hurricane destroy it?
Because of this concept called hidden technical debt. There's a very famous paper by some researchers at Google from a while back that really exposed the core of this illusion.
Oh, I think I know the one.
Yeah, we naturally assume that the machine learning model, the actual neural network, is the entire product. But in reality, the actual machine learning code is only about 5% of the total system.
Wait, hold on. 5%?
Just 5%.
That doesn't make any sense. Companies are paying millions of dollars for these top-tier researchers to write complex algorithms. Are you telling me 95% of that massive investment is missing the point?
That is exactly the reality of modern AI. That
No.
5% is just the core logic.
Wow.
Yeah. The other 95% of the system is what actually keeps it alive. We are talking about the infrastructure to handle incoming data streams, continuous monitoring, version control.
Right, all the plumbing.
Exactly. API integrations into legacy software and, the governance frameworks that make sure the model isn't actually breaking the law.
So it's literally like looking at a standalone machine learning model as this high-performance sports car engine sitting on a workbench in a garage.
Oh, that's a great way to put it.
Right. Like, it looks incredible, the horsepower stats are off the charts, but it's completely useless without a chassis, a fuel line, a transmission, and wheels to actually get it down the road.
Exactly. You can't just drop an engine onto the highway and expect to win a race.
You just cause a massive accident.
Right. And what's fascinating here is how long it took the industry to realize that. We just kept buying more and more powerful engines and then wondering why we weren't winning any races.
Which brings us to the big realization.
Yes. Since 95% of the work is building the vehicle around the engine, you need someone specifically trained to build the vehicle.
The AI architect.
Precisely. You need an AI architect.
I think the best way to visualize this shift from data scientist to architect is moving your focus from the canvas to the museum.
The canvas to the museum. I love that.
Yeah, you have to stop staring at the single painting you're creating and step back to design the lighting, the security, the foot traffic flow, and the climate control of the entire building.
That is the perfect way to frame it. An AI architect doesn't sit there tweaking hyperparameters on a model to squeeze out like 1% more of theoretical accuracy.
Right, they're looking at the bigger picture.
Exactly. They design the ecosystem where that model lives, where it can scale up to handle millions of simultaneous users without crashing, where it updates itself safely, and critically, where it is held accountable.
And the demand for these, museum designers is just skyrocketing right now.
Oh, it's off the charts.
Yeah, looking at recent global jobs reports, AI and machine learning architects are sitting in the top 10 fastest growing roles globally. They're estimating a talent gap of over 2 million people.
Yeah, it's a massive shortage.
And industry projections are saying that very soon, like 70% of organizations trying to scale their AI will have dedicated AI architecture roles.
Because the return on investment is impossible to ignore. Organizations that adopt this mature architectural approach, which is often called MLOs.
Machine learning operations, right?
Right. They see a 40% reduction in deployment time, but even more importantly, they see a huge drop in drift or latency incidents in production, like 35% fewer crashes.
Here's where it gets really interesting, though. Does this mean the traditional data scientist is obsolete?
Not at all.
Because if I'm a business leader listening to this, I might think, great, I'll just fire my data scientists and hire a mythical full-stack AI unicorn who can do the math, build the servers, and handle corporate compliance all by themselves.
Yeah, if we connect this to the bigger picture, chasing that full-stack AI unicorn is a complete recipe for disaster.
Really?
Oh, absolutely. Nobody masters everything. True AI architecture is a highly collaborative team sport.
Okay, that makes sense.
It requires deep integration between software engineering, data science, cybersecurity, and infrastructure. The data scientist isn't obsolete at all.
Their role just changes.
It becomes highly specialized. They focus intensely on building the best possible 5% engine, while the architect focuses on how that engine securely drives the rest of the business.
Okay, so knowing this architectural role exists is one thing.
Yeah.
But how does someone actually make this transition without getting completely overwhelmed?
It is a lot to take in.
Right, because going from running Python scripts on your laptop to designing a massive corporate AI ecosystem sounds terrifying.
It does, but it really just requires bridging 3 main competency gaps.
Okay, what are they?
First is the focus gap. You must shift your mentality from model-centric to system-centric.
Right, canvas to museum.
Exactly. The second gap is infrastructure. This means moving away from local single machine processing.
So getting off the laptop.
Yes. You have to understand distributed clusters, Kubernetes orchestration, serverless deployments, and feature stores.
And the third?
The third gap is governance. This means moving beyond just checking if your math is right and stepping into the world of compliance, traceability, and risk management.
Let's put a face to this to see how it actually plays out.
Okay.
Imagine a data scientist. Let's call her Laura. She works at a mid-sized fintech company.
Good context.
She's brilliant.
Yeah.
She spends months training a new credit scoring model to predict loan defaults, and it hits a 92% accuracy rate in her sandbox.
Nice.
She's thrilled. The executives are thrilled. They push it to production.
The hurricane hits.
Hard. Within 3 weeks, the model starts failing spectacularly. It's approving risky loans and denying safe ones.
Oh, no.
Why? Because out in the real world, the underlying economic data shifted. Interest rates changed. The data inputs coming from external APIs changed their formatting.
Right. So the model was suddenly reading blanks instead of numbers.
Exactly. And even worse, the underlying data sets she used weren't versioned.
That is a classic failure cascade. Without data versioning, when the model breaks, you don't know what data it was originally trained on versus what it's looking at right now.
That sounds like a nightmare.
It is. It's like trying to fix a recipe while someone else is actively replacing the ingredients in your kitchen while you cook.
Yeah.
And because there was no drift validation, no system raised a red flag to say, hey, the financial data today looks wildly different than the data we trained on 6 months ago.
So Laura realizes she can't just keep training new models. She needs to bridge those 3 gaps.
Right. She needs an architecture.
So she embarks on a 12-month transition to become an AI architect. Months 1 and 2, she completely immerses herself in cloud AI architecture.
Which is the foundation.
Yeah, she stops relying on her laptop and learns how the big cloud providers structure their data pipelines.
Then, in months 3 and 4, she tackles the infrastructure gap. She implements a feature store and a model registry.
Let's pause there because feature store is a term that gets thrown around a lot. What exactly is she building?
Think of a feature store like a commercial kitchen's prep station.
Okay.
In traditional data science, every time someone wants to build a model, they have to clean the raw data themselves, standardize the dates, normalize the currency, handle the missing values.
They're doing it all from scratch.
Exactly. They are chopping their own onions from scratch every single time. A feature store does that work once, centrally.
Oh, that is so much more efficient.
It stores all those clean, validated features like a user's 30-day transaction history, so any model in the company can just grab them instantly. It guarantees consistency.
That makes total sense.
Yeah.
So by months 5 and 6, she has this consistent data, and she starts building CI/CD pipelines.
Continuous integration and continuous deployment.
Right. But here's where I get tripped up. Software engineers have used CI/CD for years to push app updates. Why is CI/CD for machine learning so much harder?
Because software code doesn't rot.
What do you mean?
If you write a sorting algorithm today, it will sort numbers the exact same way 10 years from now. But AI models are built on data, and data decays.
Because the world changes.
Exactly. Human behavior changes, markets shift. So AI architects don't just use CI/CD, they build continuous training pipelines.
Continuous training.
The system is designed to monitor the real-world data, and the moment it detects that the world has changed, it automatically triggers the pipeline to retrain the model on the fresh data.
Without a human having to do anything.
Right. It trains it, validates the new model's accuracy, and deploys it all automatically.
And as part of that pipeline, she builds an automatic rollback feature.
Yeah, right.
So if the newly trained model actually performs worse in production, the system instantly reverts to the older, safer version.
Exactly. That way, Laura doesn't have to wake up in a panic at 2 a.m.
Which is the dream.
Truly. Then we hit months 7 through 9, bridging the governance gap. She integrates governance dashboards directly into these pipelines.
So she's tracking everything.
Everything. She implements strict traceability. Every time a model makes a decision, the system logs exactly what version of the model was used, what snapshot of data it was trained on, and what parameters were applied.
Finally, by months 10 to 12, Laura is leading the platform design for her entire business unit.
It's a massive evolution.
In 1 year, she evolved from someone who just makes models to the architect of a secure, scalable, self-healing ecosystem.
It is. But it is vital for you listening right now to understand the underlying rule here. Less is more.
So what does this all mean for the listener? Because if I'm hearing this roadmap, I might be, like, hyperventilating.
Oh, for sure.
Thinking I need to master Kubernetes orchestration, continuous pipelines, and international risk frameworks by Monday morning. It sounds like an impossible mountain.
Well, it is impossible if you try to do it all at once. The transition must be incremental. You don't boil the ocean.
Start small.
You start by mastering just one end-to-end pipeline, follow a single piece of data from ingestion through a basic transformation into a simple model, out to deployment, and set up one monitor.
Just one thread.
Just one thread.
And then once you understand how that single thread behaves in the hurricane, then you can add complex orchestration.
Exactly. Mature architecture isn't about chasing the latest technology fashion or cramming 20 different trending tools together.
Right.
It prioritizes interoperability. The best architects build systems where a few highly reliable tools communicate seamlessly.
That actually brings us to the real-world hurdles. Because Laura's roadmap is inspiring, but companies out there are hitting massive practical roadblocks.
Always.
Let's talk about budget. GPUs, the massive computer chips required to run these AI models, are incredibly expensive.
Extremely.
Small and medium enterprises simply don't have the capital to build dedicated AI server farms. How does an architect solve the money problem?
This is where architectural strategy really outshines basic data science. A lot of recent industry data shows that a huge majority of successful AI deployments in mid-sized companies use a serverless first approach.
Meaning they don't keep servers running 24/7.
Right. In a serverless architecture, the system scales to 0 when nobody is using it.
Oh, wow.
Yeah. If a customer sends a request at 3 a.m., the cloud spins up the exact amount of compute power needed for that 1 second, processes the prediction, and spins back down.
So you pay for the second, not the server. But architects also alter the models themselves to save money, right? Using techniques like model quantization and distillation.
Yes, and these are brilliant mechanisms. Take quantization, for example.
Yeah, break that down for me.
Think of a massive AI model's math, like an ultra-precise GPS coordinate with 10 decimal places of accuracy.
Okay.
Calculating that requires massive computing power. Quantization essentially rounds that math down to, say, 2 decimal places.
Does that ruin the model?
Not really. You might lose a tiny fraction of a millimeter in theoretical accuracy, but the calculation suddenly runs 100 times faster. It takes up a fraction of the memory and costs pennies instead of dollars to execute.
That is wild. And the escalation is kind of like having a professor teach a student.
Exactly.
You take the massive, expensive teacher model and you have it generate thousands of examples to train a tiny, cheap student model.
Right.
The student model can't write a novel, but it learns to do one specific task incredibly well for a fraction of the cost.
Precisely. Architects use these techniques to navigate budget constraints while dealing with what the industry calls tool fatigue.
Tool fatigue. Yeah, there's so many tools.
The ecosystem right now is chaotic. Every day there is a new framework. The most valuable skill an architect has is the discipline to build simplicity into that chaos.
And they really need that simplicity because of the most rigid constraint of all, which is the law.
Oh, yes. The legal side.
Right. If we look at things like the European Union's new AI laws or international ISO standards, the days of deploying a black box algorithm and just hoping for the best are completely over.
Gone.
If you are building a high-risk system like credit scoring, healthcare hiring, the law demands exhaustive technical documentation, continuous risk evaluation, and absolute traceability.
And this is why the sandbox model completely fails today. You cannot reverse engineer compliance onto a model that is already live.
It's too late by then.
Way too late. Architects must integrate compliance by design from day one. Every piece of data must have a clear lineage. Every model decision must be auditable.
So it's literally like putting brakes on a Formula One car.
Brakes on a race car, yeah.
You don't build brakes for a race car because you want to go slow. You build the best brakes in the world so the driver has the confidence to go 200 miles an hour without hitting a wall.
I love that.
That's what an AI architect is doing with governance. They are building the brakes, the traceability, the automatic rollbacks, the data validation, so the company can innovate and deploy AI at breakneck speed, knowing they won't crash into a massive lawsuit or a catastrophic system failure.
That analogy just hits the nail on the head. But, this raises an important question about where this role goes next.
Right, because the tech isn't standing still.
Exactly. The tools that architects use to build these systems are becoming incredibly advanced themselves.
Right. Looking over the horizon toward the next few years, we are seeing the rise of AI-augmented architecture tools.
It's getting meta.
It really is. We are entering an era where AI is helping to build the AI ecosystems. These agents can look at a dataset and automatically generate the infrastructure code, configure the clusters, and write the setup files.
They are already reducing the time it takes to design complex pipelines by 30% to 40%.
Which is a staggering leap in productivity. But it fundamentally shifts the value of the human being in the loop.
It really does.
And this brings us to a really provocative final thought for you, the listener, to mull over. If artificial intelligence is increasingly going to be writing its own configuration files, spinning up its own servers, and auto-generating its own continuous training pipelines.
Then what does the human do?
Right. The ultimate value of a human AI architect is no longer in writing the code.
The true value shifts entirely to human judgment. As the AI gets exponentially better at answering how to build the pipeline, how to deploy the code efficiently, the architect's job actually elevates.
How so?
It becomes deciding what systems actually deserve to exist in the first place.
Oh.
It becomes designing exactly how those systems should fail gracefully when things go wrong, ensuring a banking glitch doesn't ruin a customer's life.
It's about taking ultimate, strategic, and moral responsibility for the trustworthiness of the technology.
Exactly.
As AI masters the how, the human architect's ultimate job will be answering the why and the should we.
It is a profound evolution. We are moving from individuals translating uncertainty into math to leaders translating human values into global automated systems.
It really is profound. Remember, AI isn't built with isolated notebooks sitting on a single laptop. It is designed within living ecosystems that breathe, that scale, and that are held accountable to the real world.
Perfectly said.
We hope this deep dive gave you a new lens to view the incredible systems running behind the scenes. Keep questioning your own learning path and keep thinking about the museums you want to build, not just the canvases you want to paint. We'll catch you on the next one.